Hello, welcome. Let's try to solve another Leetcode problem 240, third 2D matrix 2. So for this problem, we are giving m times an integer matrix, and we need to write an efficient algorithm. I think this is very important, efficient algorithm that searches for a value target. So for this example 1, the target is 5, so inside of the matrix we're going to find a value which is equal to 5. So integers in each row are sorted in ascending order. So in each row it is sorted in ascending order, and in each column it is also sorted in ascending order from top to bottom. So top to bottom, left to right, it is always sorted in ascending order. But we need to find this target. Definitely we cannot solve it in O(n) square, because that's gonna be too easy. So we're gonna, instead of that, we're gonna solve it in O(m plus n) time. So this is gonna be linear. But how can we solve it like that? So instead of checking element one by one from the left to right, top to bottom, we're gonna check the element. We're gonna first check the element from the top right corner. So we're gonna check this element, and we're gonna compare with our target. Currently target is 5, so we're gonna compare this value 15 with 5. So if it is bigger, so that means all the elements below 15 gonna be bigger than 5. So definitely we're gonna shift to this column. And we're gonna check 11. 11 is bigger, and then we're gonna shift to 7, because 7 is bigger than 5, and then all other elements below 7 gonna be bigger than 5. So we're gonna shift here. So from here it is 4. 4 is less than 5, so what are we gonna do? So this means all the elements at the left side of 4 gonna be smaller than 5, but we need to find this value, target 5. So this means we're gonna shift to the row, so the row gonna plus 1, it's gonna be this row. And then we're gonna check this element 5. 5 equal to the target, so we're gonna return true. Otherwise, if we cannot find it, we're gonna return false. So in this way, we solve the problem in O(m plus n) time. So basically, we reduce the time complexity from O(n) square to O(m plus n). So we're gonna prepare the length of the matrix, and the row of the matrix, and the column of the matrix. So now we're going to prepare two variables. Let's name it row and column, R and C. So R gonna be starting from the top right, so the first row, last column, so it's gonna be so R gonna be 0, and the column gonna be C minus 1, so it's gonna be the last column and the first row. So while R less than, let me think about it. So so we're gonna find this one. This position is gonna be the first row and last column. So this means for our row, it should always less than the capital R, and the column gonna always be more than or equal to 0. So this is our condition. So in this way, we're gonna check all the elements. So if matrix RC for this element equal to target, basically this means we've already found it, so we're gonna return a true. And if matrix matrix RC, if it is more than target, so basically we need to shift to the column. Else this means it is smaller than target, we're gonna shift to the row. Otherwise, if we cannot find it, we're gonna return a false. Now let me just run it to check if it works. As you can see, it works, and it's pretty fast, and the time complexity is O(m plus n). I think that's all about it. Thanks for watching. See you next time. Yeah, I think the speed is just okay, because anyway this is O n plus n time complexity, because for each of the time we're gonna shift the column, we're gonna remove all those, we're gonna remove all those, and then we're gonna remove all the column, and then we're gonna remove all the rows. Yeah, so the time complexity is gonna be O n plus n. I think that's all about it. Thanks for watching. See you next time.